Okay, so for number 5, you want to find the x-coordinates of all critical points. So the first thing you have to do is take the derivative. So this would be the quotient rule, which would be f prime times g minus f times g prime all over g squared. So that would be the derivative of f of x, which is 6x, and then leave g alone, which is x to the third, minus 3x squared minus 3 times 3x squared all over x to the third squared. So next thing you want to do is simplify this. So if you do that, you multiply, it'll become 6x to the fourth, and then minus, so this one to this one is 9x to the fourth, and then plus 9x squared. Okay, so since, and then all over x to the sixth. So since these have common exponents, you can subtract them. So that'll change it to negative 3x to the fourth plus 9x squared all over x to the sixth. So that can still, you can factor out negative 3x squared. That would change it to x squared minus 3 all over x to the sixth. And then you can cancel out the x here and change it to x to the fourth. So the next thing you do is you can bring this x to the top. So instead of being negative 3 times x squared minus 3 all over x to the fourth, it'll be negative 3 x to the negative fourth times x squared minus 3. Okay, so the next thing we do is we set it equal to 0. So I'll move it up here. So negative 3x to the negative fourth equals 0. Divided by negative 3 is still 0. And then x to the negative fourth, in order to equal 0, would always be 0. So x equals 0 for this one. And then for the other one, x squared minus 3 equals 0. So plus 3 equals 3. And then take the square root of x squared. So x equals the square root of 3. So now I can erase all this work. Hold on. 1 second. Okay. So now that we have the x-coordinates of the critical points, now we need to draw a number line. So on this number line, 0 would be right around here, and then the square root of 3 is a little over 1, so it'll be around here. Square root of 3, it'd be plus or minus the square root of 3. And this one would be minus 3. So now we can choose a point since it's 3 different intervals. So there's an interval right here, 4 different intervals. So I'm going to choose -2, 1, 1, and 2. So now I have to plug it in to these two equations to find out if the sign will be a negative or a positive. So if I plug in -2 to this one, okay, so to plug it in, it'll be -3 times -2 to the negative fourth. So that will change to -3 over 2 to the fourth. So that'll always end up being a negative. So the first one will be a negative. Then for the second one, we plug it in and we get a positive, positive. So negative times a positive equals a negative. And then for the next interval, we choose 1, we plug it in. It'll still be negative. And then for the second one, it'll be a negative as well. So negative times a negative is a positive for this interval. So the next one, when you plug in 1, it will be another negative, and then another negative. So that'll become a positive again. And then for 2, for the second one, or for the first one, it'll still be a negative, and the second one would be a positive. So this one will be a negative. So what this means is that it goes downward, then upwards, then still upwards, then back down. So it looks something like that. So let's see. The next thing we would do is plot or state the intervals. So this line is hold on. It's decreasing at points negative infinity to negative radical 3 and radical 3 to infinity. And then it's increasing at points negative radical 3 to 0 and 0 to radical 3. And the last thing is it is discontinuous at x equals 0. And that's it for the first question. Okay, so for number 7, which was the hardest one, you do the same thing as you did for number 5. So the first thing you do is do the derivative of this whole function. So the derivative of the first part right here is a chain rule. So it'll be, if I do it really quick, it'll be negative 1/3 times x minus 4 times, to the 2/3 times 1. And then that'd still be minus 4/3 times x minus 4 to the negative 1/3 times 1. Okay, so now that I got the derivative, I can find the x-coordinates by setting this all equal to 0. So when I simplify things, I can see that in any shape or form, the first part will be x is equal to 0, like always, and the second one will be x is equal to 4 after I do the math in my head. Okay, so now that I know my points, or my x-coordinates, I draw a number line. So on the number line, 0 would be about here, and over here would be about 4. So now that I have 1, 2, 3 intervals. So for this one I'm going to choose 1, and for this one I'm going to choose 2. And this one I'm going to choose 5. So when I plug it in, I get the first sign will be a positive because it's equal to 0. And then the second sign would be, negative for this one. So plus times minus equals a negative. And then for 2, if I plug it in, it'll be a positive first, and then it'll be another negative. So, which will mean it's another negative. Then for 5, the first one will be a positive again, and then the second one will be a positive because I plugged it in to the upper equation, the top equation, which would be a positive. So it would look like down, negative, and then go back up. So now that I know this, I can plot my points, or plot my intervals and when they're decreasing and increasing. So let's see, let's write this down. Okay, so they're decreasing at negative infinity to 0 and 0 to 4. And then they're increasing from 4 to infinity. And last but not least, there are no discontinuities. Okay, and that's it. Thank you.